Hello everyone. Today we are going to discuss parametric equations of hearts. If you Google equations of hearts, you would see a lot of different types of equations for drawing hearts. This one is my favorite. It's a parametric equation form, and x equals 16 times sine of t cubed. Y is a linear combination of cosine of t, cosine 2t, cosine 3t, and cosine 4t. The parameter t is in the interval from 0 to 2 pi. I'm going to explain how do we draw heart using these equations in GeoGebra and Microsoft Excel. First, let's look at a demonstration. This is GeoGebra. It is a mathematical education software. It is free, but very powerful, and it become more and more popular in recent years. Okay, let me explain how do we draw hearts in this platform. GeoGebra supports different type of equations. Simple one is y equals x, a straight line, y equals 2x plus 1, and x squared plus y squared equals 1. The software also supports parametric equations, different format. Inferences, x coordinate, cosine of t, and a comma, y coordinate, sine of t. You see, we got a unit circle. We can duplicate the equation in apply a multiplier. For example, for our x coordinate, apply for 2, have a different shape. Multiply 2 for y parameter, we got a larger circle. We can duplicate the input. We can also make additions to decide the location of the circle. Plus 1. And minus 3. Now we are ready to draw the heart using the parametric equations we just showed. Okay, x coordinate, sine t 16 there, and cube. There's a y coordinate, and the x coordinate is 13 cosine of t minus 5 cosine of 2t minus 2 cosine of 3t minus cosine of 4t. Okay. It's quite large. There we go. So you see, when I did the input, the system automatically identifies t to be the parameter, and it is between 0 and 2 pi. This is pretty smart. Okay, now let's go back to the demonstration. Still running. Can we stop it? So in this program, I draw 9 by 9 matrix of heart at the same time. So I did it by a double sequence. A sequence of sequence. Each element in the sequence is a curve, is a parametric curve. And I also 16 times sine t cubed and so on. Apply a multiplier and apply a shift to decide the position. So the multiplier decide the size and the shift decide the location. So in the program, the size and the location is controlled by a function driven by a slider we call the S. When S is changing, and then the heart become larger and smaller and then moving around. Okay, L1 is the initial location, -4, -4, -4, -3, all the way to +4, +4. The final location of all the heart is in the origin, the center, 0, 0. And the size is also a function of S, and it is also controlled by piecewise function. When X is less than a number, it is constant. After that, it's a linear function. It is defined to be like this. And there's another piecewise function, Gx. This is used to decide the size of the function. This looks complicated, but actually there's only 2, 3, 4, 5, 6, 7, 10 or 11 sentences to complete this complicated work. It's not that bad. One thing is that in this program, I defined, for example, capital N to be 9, so define a 9 by 9 matrix, and each element in the matrix is a curve, and it also time dependent. So it's a lot of computations in the programs. So that's why the demonstration looks a little bit slow. If I use a larger number, like 11 by 11 or even larger, my computer may got crashed. But anyway, this is the demonstration for GeoGebra. Let's move to next part for Microsoft Excel. So Microsoft Excel doesn't support parametric equation. Then how do we implement, how do we draw hard using the parametric equation like this? The key is to discretize the parameter. So t is between 0 and 2 pi. So we can pick 100 points in the interval. Like ti equals I over 100 times 2 pi. And for I from 0 to 99. For these 100 points, we calculate xi and yi according to the parametric equations. Then we plot these 100 points. Let's take a look. You see, I already put a constant pi here in F1 position, and I from 0, 1, all the way to 99 here. And xi and yi is the calculation based on the equation. Then we draw our graph. Insert. We use scatter plot. Okay. There we go. It's very easy. You can, change the background, change the color, and make it look nicer. Several years ago, I created another demonstration. So I use 5,000 randomly points in the unit square and move all the points to their desired location according to the Hart equation. So finally, all 5,000 points are moved to the boundary of the heart. So you see the heart become a smoother curve. Well, that is all I have today. Thank you for watching.